Hello, welcome back to another Learning with Rhyme. Today we're going to look at the rotor. We're going to take this rotor down to the bench and we're going to talk about how to test this rotor and make sure this rotor is in good working condition. We'll conduct all those tests and then we'll use a power supply and a rotor tester to verify all the tests that we have done. So let's go to the bench. We'll take a look. We'll see you there. All right, so I have my rotor here. The first thing I'm going to take a look for is I'm going to take a look at these two slip rings that are going to be the either ends of this rotor coil inside these two pole piece halves. I'm going to take a look at the condition of those slip rings. I'm going to look for any pitting, any scoring, any carbon arcing that are on those two slip rings. If they are in need of addressing, I'm going to use 400 grit sandpaper, and I'm going to put this rotor in a device that'll rotate it while applying that sandpaper to clean up any corrosion, arcing, pitting, etc. on those two slip rings. Now, a couple tests I can do on this rotor. I can check for short to ground failures. Now, I should not have any continuity or flow between either of these slip rings to this shaft or to these two pole pieces. Now, to check that, I'm going to put my multimeter on a resistance reading. I'm going to touch one of my leads to one of those slip rings, and I'll touch the other lead to that shaft on both ends. Make sure I have no continuity. Good. And then I'll go from the slip ring onto both of my halves of my interlacing pole pieces. I should have no continuity. This rotor is good for short to ground failures. The second check I'm going to do, I'm going to get a resistance reading of that coil inside, but the first thing I'm going to do is I'm going to take a look at what the internal resistance of my multimeter is. I can see there I've got about 0.1 ohms. Let's write that down. Second, I'm going to take a resistance value across those two slip rings. I'm going to get that resistance value of 1.9 ohms in this case. For the most accurate reading, I'm going to take that internal multimeter resistance out of this rotor reading. So my total rotor is going to be 1.8 ohms. Now, what can I do with that information? Generally speaking, with our rotors, the range that we use in the classroom is going to be a 2 to 10 amps draw across this coil inside this rotor. I'll find specifications in a book, and they usually fall somewhere in that 2 to 10 amp range across that rotor coil. Now, that's all fine and dandy. I have a 1 ohm draw across that coil. I can apply that 1.8 ohms into my resistance portion of my triangle here. For most rotors, the voltage applied will usually be 10 volts DC. Using these two values, I can find what my amperage draw should be across this rotor coil. If I take my 10 and I divide it by my 1.8, I should see about 5.55 repeating as my amperage draw across that coil. Now that amperage draw falls nicely into my 2 to 10 amp range. So what else can I do with this resistance value? Let's say I jump across these two terminals and I get a resistance value of 0.5 ohms. If I use that same 10 volts draw, 20 amp draw, which is quite excessive. With that high of an amperage draw, this rotor is going to pull in a whole bunch more heat and we're going to burn that coil up. Now that's all fine and dandy. Let's take this information and let's test it on a rotor tester. We're going to put a voltage to these two terminals and see what our amperage draw is going to be. All right, so next we're going to take a look and apply those numbers that we got in our first equation that we looked at on the tabletop. I have my same rotor, my two slip rings. What I'm going to do is I'm going to hold those two slip rings down to these two contact points. Those two contact points, I'm going to be able to apply a controlled voltage using this dial, which my power supply will then determine or read for me my amperage draw that I'm going to draw across that coil. It should be somewhere in and around the 5.55 amps range. So let's hook this back up. I'm going to plumb this into my vise here. I'm going to turn my power supply on, and I'm going to have to kind of reach over here to actually see what I'm changing here. I'm going to hold that rotor onto those two terminals. And as I do that, I'm going to turn this up slowly until I get 10 volts being pushed across that coil. Looking at my number, it looks like I'm drawing 5.5 amps across that rotor coil, and that still falls within my 2 to 10 amp range, which is a good rotor for this instance. Normally, I'd take that spec and I'd compare it to actual values that I can find for whatever alternator this rotor came out of. Sure, the number or range that we like to use in class is that 2 to 10 amps range for that rotor coil. If you found this video helpful, you know what to do. Hit the buttons below. Like I say, if I can help one more person beyond the scope of my classroom, then I've done my job and I'm happy. Stay tuned. We're going to continue to take a look at more electrical bits and pieces. See you in the next video.